Lesson 3-3, slope-intercept form. First off, what is slope-intercept form? Slope-intercept form is just a way of writing an equation for a line where you are given the slope and where you're given the y-intercept. The slope, and in slope-intercept form, is just y equals mx plus b, where m is your slope and your b is your y-intercept. So as long as you know those two parts, you could graph any line. And when you look at a graph, you can write any line, the equation of any line in slope-intercept form, as long as you know what the y-intercept is and what the slope would be. So slope-intercept form for linear equations, so again, you can only use this for linear equations, is y equals mx plus b. Here you can see the y-intercept is 7, and you have to identify another point. So they're identifying this point, but I could identify this point, and I'm going down 1, 2 over 1. So it's always rise over run. So I'm going up 1, 2. So I go from this side, 1, 2. I go up 2 over 1. That's 2 over 1. But because it's going down from left to right, this would be a negative slope. And so you have your slope and your y-intercept. So let's take a look at an example. Write an equation in slope-intercept form for the line with a slope of 4/7 and a y-intercept of 5. So again, we need it in y equals mx plus b. So we have our y equaling, our slope is our m, which we were told was 4/7. We need our x variable plus our y-intercept of 5. So our equation is y equals 4/7 x plus 5. Next, write an equation for the line with a slope of -5 and a y-intercept of 12. Again, we want to put it into y equals mx plus b. Our slope is -5, so wherever I see an m, I'm going to put a -5. We have our x variable, and then we have a y-intercept of 12, so that's plus 12 for our b. Another example, write the equation of this line. So we have y equals mx plus b. Our slope is 5/8, so I have 5/8 x plus the y-intercept of 3 plus 3. So our equation y equals 5/8 x plus 3. Example 2, rewrite the linear equation in slope-intercept form. So here we have an equation. We just have it in standard form. We need to change it to y equals mx plus b format. So again, we want it in y equals mx plus b. That means we need to get y by itself. To do that, I'm going to subtract 11x on both sides. And now I'm left with -4y equals, and here I'm going to put my x first, my slope, so -11x, and then I put my -2 at the end. Last step to get y by itself, the opposite of multiplying by -4 is divide by -4. And I'm going to divide each part by -4. Because sometimes I can simplify 1/2 of it, but I can't simplify the other half. So my equation would be y equals 11/4 x, and it's positive because a -11 divided by a -4 gives us a positive. Negative divided by a negative is always positive. And -2 divided by -4 is a positive 1/2. So our equation would be y equals 11/4 x plus 1/2. Another example. Here we need to write this in slope-intercept form. So y equals mx plus b. Need to get y by itself, so I'm going to add 16x to both sides. And I have -4y equaling 16x minus 56. To get y by itself, I divide by -4. And I have an equation of y equals a -4x plus 14. Another example from example 2. Put this in slope-intercept form, so y equals mx plus b. Get our y's by itself, so I subtract 18x on both sides, and I'm left with -3y equaling a -18x minus 27. To get y by itself, I divide by -3 on both sides, and I'm left with y equaling 6x plus 9. Example 3, we're going to write a linear equation from a word problem. Here it says the number of job openings in the United States during the recent year increased by an average of 0.06 million per month since May. In May, there were about 4.61 million job openings in the United States. Write an equation in slope-intercept form to represent the number of job openings in the United States in the month since May. So again, we need to have our equation in y equals mx plus b. And here the b is always our starting point. How much did they start off with? So what was the job openings in May? And it says in May there were about 4.61 million jobs. So I'm going to put 4.61 for my b. The x is going to be the number of months since May. And since we don't know the specific month since May, we keep that as an x. And now our slope, the change in job openings. They're saying that it increases, so that means it's positive 0.06 million per month since the month of May. So my slope would be 0.06. Our equation would be y equals 0.06x plus 4.61. Another example, in the first quarter of 2012, there were 183 million users of a popular social media site in North America. The number of users increased by an average of $9 million per year since 2012. Write an equation that represents the number of users in millions of social media sites in North America after 2012. So again, we need to put it into y equals mx plus b. The starting point would be 183 million in 2012, so I'm going to put plus 183 million. The number of users increased, so that means it's a positive number by an average of 9 million per year, so that would be 9x plus 183 million. And this would be the equation you would use to find out users in a particular year after 2012. Another example, the median household income in the United States during the recent decade decreased. So that means it's going down, which means we have a negative slope, by an average of $305 per year. At the beginning of the decade, the median household income in the United States was $56,800. Write an equation in slope-intercept form that represents the average household income in the United States since the beginning of the decade. So decrease by an average of 305 per year. This is our slope. And then at the beginning of the decade, it was 56,800. This is our y-intercept. So if we write our equation, we would have y equals slope a decrease of 305. So this would be negative 305x. And then they started with a positive 56,800. Second part of our lesson is graphing linear functions, slope-intercept form. When you graph it, you only need two parts, your slope and a starting point. Your starting point is going to be your y-intercept. So the slope and the y-intercept, those are called your parameters. Those are your key parts that you're going to use to graph a line. So your y-intercept is your starting point. So that's always the point that you want to plot first. And then you use the slope to determine where you put your next point. Now you might have a constant function, and a constant function is just a linear function in the form of y equals b, which just means we're going to have a horizontal line that crosses the y-axis. Anytime you have a constant function where b does not equal 0, do not cross. They will not cross the x-axis. So it's just going to be a horizontal line. And your slope is always going to be 0 for a horizontal line. Again, if you need to remember the Mr. Slope guy, when it goes up, it's positive. When it goes down, it's negative. When it's vertical, it's undefined. And when it's horizontal, the slope is 0. And then the last thing, the domain of a constant function is all real numbers, and the range is always whatever your b is. So I can put any x variable in there, but my y would always stay the same. So an example, graph a linear function with a slope of -3/2 and a y-intercept of 4. So I'm going to first put my point, my y-intercept here of 4 on the y-axis, and then a slope of -3/2, which means I'm going to go down 3, and then I have to go to the right 2. And why to the right 2? Because negative slopes go down from left to right. And there would be my equation. Next, graph a linear function with a slope of -2 and a y-intercept of 7. So I'm going to put a point at 7. Here I only go up to 6, so I'm going to put 7 is roughly here. Has a slope of -2. That means I go down 2 to the right 1. And I can keep going down 2 to the right 1, down 2 to the right 1. The more points you see, the more easier you can see where your line is going to be. But you just need to have a minimum of 2 points to make a line. Another example, graph this linear function with a slope of 2/5 and a y-intercept of 1. So I put a point at 1, a slope of 2/5. So this is positive, so I'm going to go up 2 to the right 5. I could also go down 2 to the left 5. And there you can see our line that goes up from left to right because we have a positive slope. Example 5, here we're going to use the intercepts to graph the function. Could you put this in y equals mx plus b to do that? You could do that, but I think the easiest way would be, one of the easier ways would be to use the intercepts. Now for this one, though, because if I were to make 12x equaling 18 and then -3y equaling 18, I would get a fraction on this side. I would get x equaling 18 over 12. I divide that by 6/6, and I get 3/2. Here I divide by 3, -3, and I would have y equals a -6. Could I plot those? 3/2 is 1.5. So I could go 1.5 here, and then the y-intercept is at -6. I would have my line like this. If I wanted to put it into y equals mx plus b, I would just subtract 12x on both sides, and I would have -3y equaling a -12x plus 18, then divide by -3, and I would have y equals 4x minus 6. And if I were to plot that at a point at -6, I would go up 4, 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1. And then you can see if I drew my line, it would pretty much line up with what I have here. So there's two ways of doing that. If it works well with just doing integers or using, even if it's a fraction that's easy identified on a graph, then do so. Otherwise, just put it into y equals mx plus b. Next, here I can see that -4, 8, and 16, they all work well together. So if I make -4x equaling 16 and 8y equaling 16, I can now find my intercept by dividing by -4 here, and I get x equaling a -4. Here, divide by 8, and y would equal 2. I can plot my points at -4 on the x-axis and 2 on the y-axis and draw my line. Or you could always solve for y by adding 4x, and you would get 8y equaling 4x plus 16 divided by 8, and I would have y equals 1/2 x plus 2. means I put a point at 2, I go up 1 over 2, up 1 over 2, or down 1 over 2, down 1 over 2. They still match up. Next, example 6. These are constant functions. So it says graph y equals 2. So I put point at on the y-axis at 2. There is no slope. So it just is a horizontal line. I can put another point somewhere here to show that it is a straight line. Next, y equals 1. So I put a point on the y-axis at 1. I can put a random point here because whatever x is, the y is still going to be 1. So I have a horizontal line. Next, match each graph with its function. So there's two sides to this one. The equation, and so here I have the y-intercept at -8. So I checked which one has a y-intercept of -8. I don't see one with with a -8 yet. But if I were to this one possibly could be, so if I rewrite this one, that would be 3x minus y equals 8. I would subtract 3x. Now I'd have negative y equaling a negative 3x plus 8. Divided by -1. I would have y equals 3x minus 8. And if I would go up 3, so 2, 3 over 1, 1, 2, 3 over 1, that matches up. So this one would be 3x minus y equaling 8. This one has a positive 8, and it's going down, so that means I have a negative slope. If I went down 2 over 1, down 2, 1, 2 over 1, this one looks like it could be y equals negative 3x plus 8. Let's see it again with this one. This is 6. So we would go down over 1, down 2, 1, 2 over 1, 1, 2, 3 over 1. So this one would match up. So we would have y equals negative 3x plus 8. And the letter C, this is a horizontal line. It crosses the y-axis at -4, which would mean this one. So y would equal -4. Now we already used these bottom ones, so we know those are our choices here. Here it says it crosses the y-axis at 8, so this one has to be y equals 8. This one it crosses at -4. And this one also crosses at -4. So one's a positive slope, one's a negative slope. I already know this is in y equals mx plus b format. This is a positive slope, which means it's going up 3 to the right 7. And then, so that means this one would have to be y equals 3/7 x minus 4. This one's a negative slope. If I were to simplify this one, 3x plus 7y equals -28. I would subtract 3x, and I have 7y equaling -3x minus 28. Divide by 7. I would have y equals -3/7 x minus 4. So this one would have to be 3x plus 7y equals -28. Next graph, y equals -5. I'll put a point at -5 on the y-axis. So horizontal line, constant function. And our last example is example 7. Says the number of online shoppers in the United States can be modeled by the equation y equals 5.88x plus 172.3, where y represents the number of millions of online shoppers in the United States x years after 2010. Estimate the number of online shoppers in 2020. So I'm going to start off with my equation. X is the number of years after 2010. So if we're looking at 2020, that is 10 years after 2010. So I would have 5.88 times 10 plus 172.3, and that would give us our y. So our y would equal 5.88 times 10 is 58.8 plus 172.3 would give us an answer of 231.1. So that would be roughly 231.1 million. Now it does say estimate, so if we were to estimate this, we would say it's about 230 million. But 231.1, that is okay for that one. Next, attendance for Division I college football bowl game can be modeled by 2,069 x plus y equaling 52,648, where y is the average attendance and x is the number of years since 2010. Estimate the attendance for Division I college football bowl games in 2020. Justify your estimates. So here, this should be can. So x is representing the number of years since 2010. And since we're looking at 2020, that would be 10 years. So all I'm going to do is take my equation that they give me and I'm going to solve for y. So subtract 2,069x on both sides. And we have y equals negative 2,069x plus 52,648. So now for x, I'm just going to put 10, which will give us a negative 2,069 times 10, which just means I just added 0 at the end, so it's 20,690 plus 52,648. So a negative 20,690 plus 52,648. This will give us an answer of 31,958. If we were to estimate that, that would be about 32,000 people, because it's only 42 people away from 32,000. So that is our lesson today on slope intercept form.